You all my lecture series of automata theory and compiler design. In today's video, we are going to see about code generation phase, the issues in the design of code generator. I recall that what is a code generation? That is a last phase of compiler. It is an optimized intermediate code is provided as an input to the code generation, and it generates the target code. The output code must be a correct one, and it should be the high quality, and it should be run in a minimum amount of time. So these are all the things we have to consider before going into generate the and design a code generator. So the input of the code generation is a optimized code, output is an assembly level code. So what are all the prerequisites in that code generator means we need to know about the target machine instruction set and the instruction addressing modes and number of registers and then configuration of an arithmetic logical unit, because our output is an assembly code, so all the statements are stored in the registers. Here we are using that how many registers, and we have do the arithmetic logical unit means we do any operations like addition, subtraction, multiplication means we have to find out the cost effectiveness of the operator also. So the issues in the design of code generator are input to the code generator. So you have to decide what is the input to the code generator, and memory management and target programs and instruction selection, register allocation, evaluation order and approaches to the code generation. We will see one by one. Input to the code generation. So the input to the code, it can be the intermediate representation. So the intermediate representation, it can be done in three ways. One is a syntax tree representation, other is a postfix representation, and other one is a three address statement, that is a quadruples, triples and things, and other one is a graphical representation like the DAG. So we have four types of representation. In the representation, which representation we are going to use அப்படிங்கிறத we have to decide before going into design a code generator. Next one is a memory management. So what is a memory management means mapping our source program to an addresses of a data objects. So we are going to mapping our source program addresses to the data object in the runtime memory. So we need to know about what is the memory management techniques we are going to do, and mapping the and code to generate the relative address of the corresponding data. That is the thing we have to consider. Next is the target program. So our target program, we have to decide the output. It may be either a absolute machine code or the relocatable machine code or the assembly code. This is a three way the output can be generated. So we have to decide with which output we have to want. So according that we are going to design the intermediate code generator. Next is the instruction selection. So the instruction selection, the factors to be considered in terms of an instruction selection are the uniformity and the completeness of the instruction set. The uniformity and the completeness of the instruction set we have to find out, and also the instruction speed and machine idioms. So machine idioms means suppose there is a instead of a multiplication operation, we can use the addition operation to reduce the cost and the size of the instruction set. So these are all the things we have to consider before going to select any instruction for the statement. So what is the completeness, what is the instruction speed, and what is the machine idioms statements, and the size of the instruction set. These are all the factors to be considered. Next is the instruction செலெக்ஷனில் நம்ம பார்த்த மாதிரி எந்த இன்ஸ்ட்ரக்ஷன் யூஸ் பண்ண போகிறோம், ஸோ அதோட காஸ்ட் என்னங்கிறத பேஸ் பண்ணி we have to find out. Next is the registers allocation. So the register allocation phase அப்படிங்கும்போது பார்த்திங்கன்னா it is a register allocation phase and register assignment phase. So the instructions with register operands are usually the shorter and faster இருக்கணும். ஸோ அதுக்கு தகுந்த மாதிரி we have to select the registers. So the efficient utilization of the registers is important for generating the good code. So the efficient utilization of the register is a very important one. The register allocation means select the set of variables that will reside in the registers, and the register assignment means pick the specific register that the variable will reside. So these two phases are in the register allocation. Next one is an evaluation order. The order in which the computations are performed can be affect the efficiency of the code. So the order of computation is also very important for generating the target code. Some computations require fewer registers to call the intermediate result than others. So you can select that type of computations for minimizing the registers utilization. So the evaluation order is a very important one. So these are all the several issues we have to consider before going into generate the code generator. One is the register allocation, input to the code generation and target program, and next is the evaluation order and then instruction set selection, register allocation, next is the memory management. So these 6 issues we have to consider. Thank you.